Hey, welcome to Trigonometry. Trigonometry, what's that? Well, here we go. Trigonometry from the Greek means a triangle being measured, if you like. Triangle measurement are the roots of those words. So we're actually doing something about measuring stuff in triangles. And you might say, hey, I know how to measure stuff in triangles because I've just done maybe something like Pythagoras. And I know the square on the hypotenuse is the sum of the squares on the other two sides, and they usually write that as c squared equals the square on the hypotenuse is the sum of the squares on the other two sides, and that's the old dead Greek, Pythagoras. What a great guy he was too, a philosopher as well. But anyway, no, that's not the only measuring in triangles. Trigonometry is measuring some other things about triangles. Well, what other things do triangles have? Oh, they have angles. So, trigonometry, measuring triangles in some ways, involve sides and angles. How does that happen? How can we do that? So what I've got here for you is a really fun introduction to trigonometry. Because what I want you to see is not just a mathematical definition, but why it works perhaps, first of all, and see some uses for it. So I want you to come down here with me, and I want you to go sailing. Okay? So here, take the helm. The helm means the rudder. Take control of the boat. Have you ever sailed a yacht? Do you know how to sail? If you don't worry. If you're not, don't worry. As you, there's a misprint there. As you can gain some ideas within a simulator. What's a simulator? A simulator, which is a program, or if you like, a machine even, where you sit and it simulates or mimics, or gives you some idea of what the real thing is like. And here we're going to use an electronic one. And I've got a website here. Just before we do that, we really have to say thank you to when it was called that, the Noel Baker Centre for Mathematics at Prince Alfred College, and two people, Anthony Harradine and Alastair Lupton, who have developed this little unit of work called Wind in Your Sails as an introduction to trigonometry, to get you excited about what's going on. So now, what I want you to do is to be able to access that website. So you might actually have to write this down on a piece of paper because you've got your computer there busy on this one. But you might write this down somewhere and come back. This is going to be a website we're going to use in this presentation. All right, so you can pause the presentation now and do that. I'm going to go on and say what I want you to do when you see the simulator. Now, this is going to come up on your screen on that website, and this boat here well, it's not a boat, it's a yacht. A yacht is propelled by a sail. Here's the sail here, and the sail enables you to capture the wind. As you can see, if the wind blows into this sail, it's going to push the boat along. That's the method of propulsion in sailing. So the aim in sailing is to capture the most wind to drive you in the direction you're going. But there's one other thing to control that, is so that you can stay on some course, you have to adjust the rudder. Now the rudder, I don't know whether you understand a boat, but if we look at it on the side here, here's a boat with a sail, etc. You can see why I'm a maths teacher and not into art, mate. Okay, well, not to worry. Okay, so here you have a rudder. So as the boat moves through the water, this water pushes on the rudder, and if you turn it, you can turn the boat. So a rudder changes the direction of the yacht or the boat, whatever you're doing. We also need one of these in a powered boat as well, basically to direct the force that's pushing you through the water. Okay, so you have these two controls. Come back over here, adjust the sail, adjust the rudder. So you can play with that. So what you need to do is toggle these with your mouse. So you can put the sail right out or in. You can adjust the rudder, and between the two, they will change the direction of the boat. Now I've got a hint for you. Move each one slowly. Slowly. And here we are. Here's the aim down the bottom, the instructions. And there are more instructions if you go down. Master rudder and sail to get your boat going as fast as possible, no matter what direction you're sailing in. No matter what direction you're sailing in, or which way the wind's blowing. So we want to try and sail like this one up here, basically with the wind coming across us or behind us, and just playing around, getting an idea of what's happening. And here we are. This is the wind speed, and you want the maximum boat speed in the direction you're aiming for. So I'm going to give you some exercises now where I want you to try to, no matter where the wind's blowing, try and get the boat going in a certain direction at maximum speed. So the aim here is to see how these two work together. Okay, let's go down here, and once you've got that window up, here are your three tasks. And this is the end of the first part then. I want you to do this as the first exercise. Using the simulator, adjust the rudder and sails controls until you have the yacht sailing as fast as possible. So this will vary from person to person, because every time you run the simulator, they give you a different wind speed. So you won't always be able to make the boat go as fast. If the wind speed isn't as fast, then the boat won't capture as much wind and the boat speed won't be as fast. So record your top boat speed and the wind speed and summarise your sailing strategy. What did you do? If the wind's in a certain direction, where did you head your boat to get maximum capture of the wind and therefore maximum speed? Summarise your sailing strategy. What did you do? What did you do to get that going fast? Where was the wind? Immediately behind you, off to the side? Where did you put the sail? Right out? Partly out? Okay, you got the idea. I want you to do that activity, actually record that either electronically in some recording method, OneNote or something like that, or in an exercise book. Task 2. Adjust the rudder controls until you have the yacht sailing due east. Now, we usually use this for the points of the compass: north, south, east and west. Now adjust your sail control to maximise your speed. Now, this is going to be also dependent upon when you start the simulator, and you can refresh it. When you do that, what wind direction you've got, because due east is only this way up here, but the wind might be coming from all different directions. So you're going to vary with your results here. But the idea here is to get maximum boat speed no matter where the wind, what wind speed is or the wind direction. And again, how did you do it? So what we're doing is getting you familiar with a navigator's problem on a sailing ship, so that you're aware of the difficulties here. If you want to go east but the wind isn't pushing you that way, what's your strategy? How do you change the rudder and the direction to capture most wind and to improve your boat speed? Okay, so you might jot some of these down and pause the presentation and go and have a go one by one. I'll just go through them. Just remember, with these presentations, you can actually pause it at any time and go off and just do that part. Okay. Task 3. Adjust the rudder controls until you have the yacht headed directly into the wind. This is hard. So you're trying to go into the wind and the wind's against you. That's not going to be good. It's going to blow you backwards, mate. Now adjust your sails to get your yacht travelling at 5 knots or more. If you cannot do this, head your boat slightly out of the wind. So if the wind's going this way and you have your sail like this, it's going to push you backwards. Okay, end onto the boat there. That's going to be hard. So what we're saying, slightly out of the wind. So maybe face it off this way a bit, because then you've got your sail able to capture a bit of wind. This is not ideal. You'd like the wind coming and pushing you probably. What did you find before in task 1? Where do you want the wind? But the boat heading straight into the wind, this one is probably not good. If we head it slightly out of the wind, then we might be able to get 5 knots. That's not very fast, but it's going into the wind. So you can see our problem. You wouldn't expect to be able to go very far or fast at all into the wind. So by heading off at an angle, here we are here, this one here, by heading off at an angle, we might be able to get the sails to capture a bit of wind. So you have to adjust the sails. You have to have a sailing strategy. How close to the wind can you sail and still achieve 5 knots? So I want you to actually answer these questions. So how far do you have to turn away from the wind to actually get at 5 knots or more? And what is the optimum angle away from the wind to get it fast? Now we want to come back and look at everybody's efforts on this and see what that angle might look like. Okay, now they are the only tasks for this part, so I want you to pause the presentation, make sure you get the idea of it. Now because I don't know how you're replaying this video, if you're doing it off the internet, off the wiki, then you'd have to close that down. You might be able to now, if you're not doing that, then you can bring up that website and refer back to the exercises between the two. All right, so let's go down. That's the first set of tasks. Now, I want you to look at this set of tasks here. A geometric model of sailing a 30-degree tack. Here's a great sailing ship here. So, if you sail a 30-degree tack, what does that mean? To sail a boat, here we are, this is the explanation here. To sail a boat using wind as the only source of power is a skillful activity. With the right technique, it is possible to sail in almost any direction, regardless of whether the wind is blowing from. But the only limitation is the boat can never sail directly into the wind or too close to that direction. The reason for that is because you'll get blown backwards. The sails can't capture any wind except forcing them backwards. Okay, and this is what you found in task 3. I think, finding an angle when you wanted to go against the wind or directly into the wind. This can mean that, for example, if you want to sail east and the wind is blowing from the east, you're forced to sail slightly off course. Slightly off course. Remember task 3, it said what angle away from the wind direction do you need to sail to get at least 5 knots? This is referred to as sailing on a tack. The result of a tack is that a boat ends up off course by a distance that has to be compensated for when the boat changes direction. That's complicated. Let's go down here and look at a picture. Here's what we just did. So just go right down there. So this is what we just did. If we want to go into the wind, then we need to angle it. So here's a calculation. We want to head this way. That's this way, into the wind. That's east. That's what we're trying to do. How far did we have to move that way to actually capture some of the wind? Because remember, it was coming in here, head on. We turned out of it, so it wasn't head on, and we wanted to get 5 knots. So if we keep doing this off the angle, we're not here. after the time we want, we're actually up there. So we're actually off course. How far off course? You take where you want to be and measure 90 degrees to where you are. That's the off course distance. 90 degrees angle from the intended direction. Okay, so we're going to try and do, you can see mathematics coming here, can't you? You can see it. It's going to be a right angled triangle. And we're going to try and make up a triangle to summarise the maths in sailing on tack. For example, if a tack of 30 degrees, I wonder if why did they choose that? Away from the wind direction is sailed for a given distance. How far off course will the boat be? Let's do some maths now. Okay, so I've flicked up the wrong way here. Let's go down here. So your exercise is this. This is an exercise for you now. I want you to start with the boat and draw a line here with a ruler accurately, and then with a geoliner I want you to construct an angle or measure an angle of 30 degrees very accurately. Then I want you to measure along this line. So this is our tack. We're supposed to be down here and we're up there. So I want you to make a scale. Okay. We want to say maybe go 10 kilometres. So 10 centimetres on your page isn't too much. 1 centimetre represents 1 kilometre perhaps. And I want you to go on scale, let's say 5 kilometres, get to the end, and then with a geoliner down here, line it up so that this angle, not that one, not this one here, not that one, but this one down here is 90. Because the definition of off course, so this is intended, this is where we should be, and we've gone on a tack. So we're up here and we're this far off course. And the definition of that, off course, is the distance from where you are, off course up here, away from the perpendicular, or the distance from there, making a perpendicular with the intended direction. So the 90 degree has to be down here. You have to put your protractor here and line it up. I want you to do several of these. Do the construction accurately. Do the construction accurately. Always 30 degrees in that first corner. For distances on tack, distance travelled, of. Now I've suggested the first one, 5 kilometres, and then 10 kilometres, and then maybe 15 kilometres, 20 kilometres, and 25 kilometres. 5 constructions. Might be getting a bit big for your book down here. Do you want to change the scale? It doesn't matter what the scale is, just remember what you're doing. You're starting off at a point, drawing a straight line across here with a ruler, measuring 30 degrees, and then to some scale going out here. So can you fit 20 kilometres on there? So that's your construction. Then you continue this line and you want to put the protractor here so that this will line up and make a 90 degrees there. Okay. Or of course, if you're into a bit of mathematics, you know this one will always be 60. So you could put the protractor up there and measure 60. But you must create a 90 here, because the definition of how far off course you are, that's what I want you to measure at the end, of how far off course you are. Don't need this one. This is where you're supposed to be. This is where you are. So how far off course? So you will I want you to make up a table now. Here it is down here. Let's just put that picture. Distance travelled on 30 degree tack. So you will have 5, you can do more if you like, 5 kilometres, 10 kilometres, 15, 20 and 25. So they are maybe, you can try more or different ones if you want. and the distance travelled off course. This is that perpendicular side. How far off course are you? I want you to make that table up and record it, please. Okay. So I might pause the presentation now and go off and make that table. Then you can come back, and what do you notice? Can you see any pattern in your table? I want you to compare these numbers here. What do you see? Do you see any pattern there? It might be worthwhile actually doing that with the whole class. So I'll just go back here. So here, if everybody compares, can you see a pattern? You might pause the presentation now and have a go. And the final question, which I just flashed down to and go back again, complete the following sentence. It appears that when we create a right-angled triangle with an angle of 30 degrees, the ratio of, what's that about? When we create a right angle with 30 degrees, so that's what we've done here. These are all 30, and that was a right angle. And what are we talking about ratio here? Ratio of what? I leave you to work that out. This is the exciting start to trigonometry, measurement in triangles, and we're going to go on and see why there is something interesting happening here. All right, so from me it's cheers for now, and I'll catch you in another presentation perhaps on how to use trigonometry and why it all works. Cheers for now.